Today, let's calculate infinite product from 2 of n to the power of 3 minus 1 over n to the power of 3 plus 1. We start from 2 because if we were start from 1, then the first term would already be 0, so it's just meaningless. So if there is a limit, what that limit could be. So instead of writing everything down in details and find out the pattern, I'll just go ahead and use the reindex technique. So first, let's look at the partial product. K from 2 all the way up to n of k to the 3 minus 1, k cubed plus 1. So now we obviously want to factorize it. Right, factorize this, we have k minus 1 times k squared plus k plus 1. Factorize this, we have k plus 1, which is standard factorization. K squared minus k plus 1. This is easily verifiable. So now here we can divide both the top and bottom to this factor and this factor by k simultaneously. And so we have copy down that, copy down this, and so this divided by k. K plus 1 plus 1 over k. So that one we have k minus 1 plus 1 over k. K from 2 to n. And so there we observe, here we have k minus 1. There we have k minus 1. Up here we have k plus 1. Down here we also have k plus 1. So here I'm just going to divide this k plus 1 into this factor and divide this k minus 1 into that factor. So here I have so this factor becomes just k plus 1 divide into k plus 1. We have 1. And so divide k plus 1 into 1 over k. So we have 1 over k times k plus 1. And at the bottom, so we divide k minus 1 into first over k minus 1. We have 1 also. And we divide k minus 1 into 1 over k. So we have 1 over k minus 1 times k. So here, notice that these two factors only differ by 1. Right? K minus 1 and k only differ by 1. K and k plus 1 only differ by 1. So here we're going to use reindex technique. Okay? So first of all, on the top I have this. K plus 1. On the bottom I'm going to distribute this partial product onto this first. Right? K from 2 to n and 1 plus 1 over. Now I want to change k minus 1 into k. So simultaneously k just becomes k plus 1. We just increased index by 1. So previously we started from 2. Right, so k minus 1 start from 1. So k is supposed to start from 1 this time. So we start from 1. And here originally we end with n. So here k minus 1 is just n minus 1 last term. So we end with n minus 1 for this term. So k ends with n minus 1. Right? So basically it's the same thing. This is the same thing, exactly the same. So now we have inside the partial product, we have exactly the same representation. And if we want to cancel everything out, first let me just take out the... So here, we end with n. I want to end also with n minus 1. So I take out the last term. right? I only end with n minus 1. Separate the last term out. So last term, when k equals n, so I 1 plus 1 over n times n plus 1. So there I separate the first term, because here I only start from 2. I also want to start from 2. I separate the first term, k equals 1. So 1 plus 1 times 2. Right? Exactly the same thing. Now we have exactly the same representation, exactly the same starting point, ending point. So only have this and that. So easily just approaches. So top, this approach is 0. So here I have 3 over 2. So that's 2 over 3. Right, as n approaches infinity. So this is exactly the meaning of infinite product. Right? I take n into infinity.